Hello there, ICS2O folks. We're on our second day of for loops, and in the warm-up, you're asked to write a little program that asks the user for 5 bowling scores and then output their average. And probably your program looks something like this one, right, where you had 5 variables that were the integers and a variable for the average, and you asked each, asked the user to enter their average, and it worked just fine. The average was you add them up and divide by 5, then output the average, and it looks just great. Works just fine, right? Um, Bam. Hopefully you formatted your output okay, so it's not got a whole bunch of decimal places there. So dandy. But it probably bothered you a little bit, I'll bet, because this was a repetitive process. It felt like we were doing the same thing over and over again. So probably some of you tried to use a for loop, but you might have got stuck. And so here's the note. We're going to start the note, and we're going to in the note we're going to solve this bowling problem in a different way. Counted loops 2 was our second day on for loops. In the warm-up problem, you had to do a repetitive process, so it made sense to do a loop. But how do we keep track of a total? So in our other program, if if we put this in a for loop for counter is 1 to 5, what is your score on this game? And then you got game 1, and then you count it, then you had no way of calculating the average, because if you repeated the loop, it wiped out the old one. So it's kind of like we have to figure out how to add up all the scores while we're still asking for output, and we do that in this way. So here's the example, and I'll show you my example soon. So what we could do is we could only use one score. Let me get the touring going here. So instead of using, I'm going to say I'm going to use one score. That's it. And then my average. But what I'm going to do is I'm going to have a total variable. And my claim is that um, I don't need to ask the user for a whole bunch of games. That in fact I'm going to just use one. So let's see. For, I could say counter or games goes from 1 to 5, and then end 4. And in fact, I can improve my output a little bit by saying what was your score on game counter. So it'll say what was your score on game 1, on game 2, on game 3, and so on. And there's my um, output, and then I have to get that, right? Get score, and then end 4. I'm going to press indent, and so I'm going to just comment this word out for now. And here, just to show you how this works, right now, what it looks like. Oh, my total is an integer, right? Total is an integer. And I'm going to use total soon. What was your score on game? Okay, right now it doesn't do anything because um, it works. It looked, what is your score on game 1? What is your score on game 2? That looks all great. But the problem is, after we put in that 4, it for our score in game 1, it wiped it out the next time. So we kind of need to keep track of it. And we do that using what's called a running total. So we're going to have this total is equal to total plus score. So the idea is the new total is the old total that's in memory plus the score. And so every time I get a score, I'm going to add it to the total. It'll loop and run. Now, I'm going to get an error message, I think. Watch this. So my score on game 1 was 100. Bam, variable has no value. Well, in this line, well, score definitely has a value. It was 100 that I typed in, but total doesn't have a value. And so remember, Turing wants to calculate the right-hand side of the equal sign and then store it in the memory section for total, but it doesn't have anything for this total. So what we have to do is we have to give total a value. So I'm going to give it a value of 0, because right now before the first game. It's got a total of 0. So I'm going to assign that value to 0, and it's going to know that it's an integer. And now it should keep a running total. What it was just, and this will work, but I've commented out the output, so that's not going to work anymore. But what do I have then? Well, then I have my average. I don't have all these game variables, but I do have a running total. Total divided by 5, and then now this is going to work again. Run. So 233, whatever, it doesn't matter what the output is. My average was 608, which I know is an impossible bowling score, but you see how then my for loop, using this special line of code, allowed me to add up the total. So what I have here is the example of that. And so you want to get that into your notes, and then I'm going to talk about this line in the next section. So either copy from Turing or copy from me, I guess, and get this example into your code. We're not done yet. We're going to do some more stuff with this. It says the following line kept a running total when put in the loop. So again, what it did is we got the score from the user, then Turing looked up in memory what this value was, and then calculated this part. So at the first time it was 0, then added the first value, which was 100, 0 plus 100, then the new total was 100. And then the next time it went through the loop, this new total was 100. Whatever score I put in the next time, 33 or whatever, 100 plus 33, the new total was 133. And this piece of code kept a running total. Now, what's funny about this, and don't mess up your note here, but this is meaningless in math, right? In math class, we would have done something, oh, okay, subtract total from both sides, and then we get score equals 0. Well, remember, even though it might look like math, it's not math. This is computer science, where this is calculated first and then just stored in this spot. Okay? So don't think of this like a math equation. It's a computer science calculation. All right, dandy. What else? He says, we can count the number of times something happens by placing this line in a loop. So count equals count plus 1. So notice that whatever the count value is when it's coming along, then when this executes, it's going to look up in memory what was the old count value, add 1 to it, and then assign back into the original memory location whatever that calculation ends up being. We saw this sort of thing in Scratch when we were counting scores. So for instance, back in our Turing thing, maybe we want to count how many times we get a high score. So if score is greater than or equal to 200, we want to maybe make note of that. So maybe we'll call it high games equals high games plus 1. If I were to run this right now, I would get an error because I haven't declared or initialized that variable high game. So let's do that. And I'm going to assign it the value 0 so that when the first time it executes, it's going to be high games is 0 plus 1. And then down here, you got high games over 200. Great. Okay, now let's run this to work. So what's the problem? High games, syntax error, expected then. Ooh, I forgot my then in my if. There we go. What was your score on game 1? Okay, so I'm going to put my high game in there, and then one that wasn't so high, and then another high game, and then one that wasn't so high, and another one that was low. So it still tells me the averages. And notice that through this if, it only counted 2 high games. So we added this code, and it kept track of the number of high games. Now notice what we've done. When I pressed indent, this if structure, which was a whole thing that we studied earlier in the chapter, is inside my for structure. This is what's called nesting. This if is nested inside the for loop. So back to the note, it says anytime we use this code, this type of code, the variables need an initial value. Okay, and we saw that. Remember, and this is what we saw, we can nest structures. Be sure to plan carefully. So that means, okay, if we knew that we wanted an if structure and a for structure, would have we put the for structure inside the if or the if inside the for? Well, we need to plan carefully, okay? So we need to think about that. Notice here, we can make our code more flexible by using variables to determine how many times the loop runs. So for instance, what I mean here, whoops, not that one, that's the finished version. This one here, this only worked if there was 5 games. If the person bowled 4 games or 12 games, it wouldn't work. Well, why don't we ask the user how many games they want to put in? Var games, and it's going to be an integer, and we're going to ask how many games did you bowl? I should be nice, I suppose. Friendly output and input, but kind of Russian so you can get to your exercises. And see, whatever they enter is going to go in my for loop, and then that's how many games they'll have to enter. And notice, then I'd have to change my average. Average isn't total divided by 5 anymore. Average is total divided by games. And so by changing that input, I can make my code a lot more flexible and a lot more reusable. So if I run that here, how many games? If I want to put 2 games in, what was your score on game 1? I got a perfect 300. And on the second game, only 20. That's it, done. And it calculated the average and still counted how many times I got a high bowling game. Okay. To finish off this note, I copied my example in there. You can see that there. Hopefully you've been sort of following along and playing with this code. I just want you to notice and step back for a second about our programs are starting to get more and more complicated all the time. It's important for you, any sort of little bits of code that takes a little bit of thought, you're going to want to put a comment next to. Notice that I sort of had a colossal fail as far as I should have a header and I should have an input section and I should have a processing section. So I would lose communication marks there and marks on my program, but you should start putting comments on all little bits of code. All right, so include that in your note. Do I have anything else for us? No, that's it. On with the second set of for loops exercises, and pretty soon we're going to be able to do all of the programming assignment problems. Not quite. We still got a couple of days on loops. We talked about these were counted loops. Well, what happens if we're not sure when we want the loop to end? And we'll talk about that. We'll talk about that very soon.